Asked about problem 39, from the previous assignment, so I wanted to go ahead and do this because it's important that you understand that. So the kinetic energy of an object is the energy produced due to its motion and mass. The formula for kinetic energy measured in joules is E equals 0.5 mv squared, where m is the mass in kilograms and v is the velocity of the object in meters per second. So in part A, you are asked, So you're asked to solve the above formula for V. So here's the formula, and what that means is we want to get V by itself. So we have to get V by itself. So we're going to divide both sides by 0.5 m. So that's going to cancel out this. And then I need to undo square rooting, or undo squaring. So we're going to square root both sides. And when we do that, we get V equals the square root of E over 0.5 m. Okay, not doing plus or minus because in this context, we are dealing with just positive. So if a 1,500 kilo, so this is my answer. That would be my answer for part A. Part B, if a 1,500 kilogram vehicle is generating 1 million joules of kinetic energy, how fast is it traveling? So we're trying to solve for velocity. This is E, this is M, and you're just plugging things in. So we get 1 million joules divided by 0.5 times 1,500. Mass is in kilograms, so make sure that works. Okay, so then I can come over here and I can do the square root. And we'll have 1 million. And in the denominator, 0.5 times 1,500. And we get about 36.5. And we need units, so how fast is it traveling in meters per second? Okay, then in part C, this problem with the escape velocity, and they give us, they tell us a 100,000 kilogram ship must have a kinetic energy of, and then they give us the 3.624 times 10 to the 14th power joules to escape the gravitational field of Jupiter. Estimate the escape velocity of Jupiter. So again, we're going to use this function here. So we need to put our energy in the numerator, and so that was the 3.624 times 10 to the 14th. We are dividing by 0.5, and then we need the mass, which is 100,000 kilograms. So we're going to solve this, and we get 10 to the 14th power. So there's my numerator. Oops, I forgot to do that. Hold on, let me fix this. Okay, that's better. And in the denominator, we're going to put 0.5 times 100,000. And I get approximately 85,135, and that would be meters per second. Okay, now, want to make a comment because I did look in the answer book and realize that, and this might be part of the confusion because you may have gotten what I got right here when you solved for V, but if you look in the answer book, they have a 2 in the numerator and they don't have anything here. So I just want to point out to you that if you divide, remember 0.5 is a half, and dividing by a fraction is the same as multiplying by the, dividing by a fraction is the same as multiplying by the reciprocal, and here's how we can kind of see that. So if I multiply the numerator and denominator by 2 over 1, this cancels that out. So notice that I get the square root of 2e over m. So that's what the answer book said. So you may have looked in the answers since they were odds and had some confusion on that. This would have been perfectly fine. Leaving it with the 0.5 would be fine. So hopefully that helps you on that problem.